Okay, no apologies for going really fast through this because I've done it once. There's 2 videos on the web, one from this year, one from last year, one from the year before. So I'm really just repeating content over and over again for the sake of it. But let's do it anyway. So, you ready watching place component? I'm not apologising for going fast on this because you can watch the video and slow it down and do whatever you want. So I'm going to place a resistor, place another resistor, and rotate them to get them to look neat. Okay, good to go, that's nice, I like that. I'm going to place component, this is in connectors. Where the connectors is, connectors there. Scroll to the bottom. And where is she? There she is. So test point THD through hole, as you know, that's what THD stands for. And one, we want 4 of these. 2, 3, 4. Okay, so we close that. Let's get these rotated so they look right. So I want to go counterclockwise with that one, counterclockwise with that one, clockwise with that one, and clockwise with that one. Okay, now let's get them aligned, so I'm going to drag, try and make it look a bit neat. It doesn't matter, this isn't the layout, this is just a circuit diagram. Remember, we don't get the layout until we go off into multi-board. Not too bad, I don't think. And that one across to there. Okay, that's it. So let's wire it up now. So that's there, that's there, that's there. There, and finally, there's there. Very simple circuit, potential divider. Don't be fooled by simplicity. Simplicity is something that repeats itself regularly through electronics, and you'll see that circuit or the reactive form of it many times. Okay, why I can't export to a PCB is because these are virtual components. They don't have a footprint. So the first thing I need to do is I need to click on it, then right-click Properties. I need to go in Edit Package, and then I need to select the database. Now remember what I was doing in here before. I can look for res, so I'll do that the first time round. So I'm just going to scroll down and look in that package column until I find RES. I nearly did, and then I lost it there. RES. Let's go to the 1500 one, the same as we did before. I can select it, say OK, bingo. It's turned blue. Okay? So that means that it's got footprint. It has a physical presence on the printed circuit board. Now let's do the second one, but let's do that using the filters. So I go to Properties, I go to Edit Package, select from Database. Now I'm going to run a filter. So I turn the filter on, I want to add a row, and in this particular case, I want to go into here and I want to SMTTH, and I want the operator for TH. In other words, I want through hole. I want to filter everything that's got TH after it. Lo and behold, look, lots and lots, but not as many as there was before. So I'm a bit closer to finding the footprint I want. Let's turn another filter on. I can tell by the way it's gone quiet. This is the bit people didn't get. So in here I can add a row now, and what I can say that I want here is I want package, because that's the column which has got the description in. I don't want equals, I want contains, and I want the word res, the resistor. I OK it, and you notice that all I have here now is the resistors. Yeah? Wonderful, wonderful. So 2 filters. But that was a lot of effort turning those filters on. But what I can do before I lose these components is I can say, well actually I'll take this component and I'm going to copy it to my database, my user database, and it will be there next time I want to use it. And the time after that, and the time after that. I can do that with every single resistor which is there. So I can create my own database, which is much, much smaller than the big database where I get a headache for everything. Yeah? So we can do that anyway. So, yeah, so we'll select this one, select OK, excuse me. So now these have got footprints. The fact that J1, J2, J3 and J4 are green means they have a footprint that you can't change it. That's what that green means. Well, that's fine. You don't want to change it, right? They're just board pins. They're holes in the board where you're going to solder bits of metal in. Fine. Absolutely fine. I think we're ready to run. So we save it. We now want to transfer to multi-board and click and commit. It's going to ask us for the name. Well, we'll get it's called design1.multiboard or EWNet or whatever that stands for, I don't really know. And that should open multi-board. Okay, I haven't got any complaints down the bottom because normally you'll see things flashing down the bottom if it's not happy. That all looks sensible. I can't change anything even if I want, so I OK it. Now, if you look down the bottom here, this is where most of your messages are going to come up. Import netlist, everything's done fine, and there's no DRC. So DRC is design rule check, and it's not flashing red. So that means it's happy with the design. So now I go through the process, and this a lot of people find tricky, but don't drag the pads. Drag these in, doesn't matter where, just drag them into the drawing area first, so you can decide. These pads are really difficult, you can't move pads, so sometimes you have to zoom in to get one. Drag those in, drag that into the drawing area, and lastly that one. Right, so zoom back out again. What do I need to make this look like? The original circuit. Well, if I rotate that nicely clockwise, I think I'm getting somewhere near it. Drag that over there. Drag this pin here. Over here. And nearly there. So that's the other input. Oops, drag the pin again. Still there. Drag that. Everything out, something like that. So now, I mean, it's only aesthetics, and this is what you'll be doing with your VU meter. It's quite important where you place these components, because this is the final positioning of them. And like I say, it's an art form. If you do it right, it looks good. If you do it wrong, it looks rubbish. So have a little think about the ways in which you're going to arrange the locations of these, okay? I'm not going to stand on ceremony, I'm just going to get these so that they're roughly right, and then I'm going to produce my printed circuit for it. Okay, that'll do it. I'm not going to dwell on it. So there we are, and that's what's called a rat's nest. If you've ever seen a rat's nest, you probably don't want to see a rat's nest. But you see a rat's nest, it's a bloomin' mess in the real world of rats. A rat's nest is just a series of interconnections, but they're not physical, they're virtual. So it's just how the circuit is wired. But your simulator needs to know what the rat's nest is before it can make the copper interconnects. So the next thing I want to do is go to auto route, and remember what's going to happen is I'm going to route top and bottom because I haven't turned the bottom off. Start using auto router. And I've routed on the top, so I've got green pads, but we're through hole. Remember what Mike said? If we go through hole, we're going to put copper on the bottom normally, right? So if I want to do that, what I need to do is I need to go to copper layers and the copper top. I actually want to turn that off for the time being. If you're going too low, you wouldn't turn it off, you'd leave it on. And that looks fine, and so now I've got red, which indicates to me that it's on the bottom. That copper's on the bottom. I haven't got any design rule checks, so everything's fine. But the copper pads are so thin, they're thinner than a hair, actually, what you see there. So I need to go a lot thicker than that, so I'm going to go to nets, and I'm going to set the minimum width to something that's a bit more sensible. And I reckon 50 is about it, that's what I'm going to opt for. And you can see that my track up above has now gone a lot fatter than it was. There's the 50 in there, and there's the 50 in there. So that looks a lot more like a sensible printed circuit board now, doesn't it? Now I can look at that in the virtual world, but let's just modify the size of the board outline now. Well no, let's place some graphics first. So graphics, let's put some text in there. And my name's John, so John is great, obviously. And I'm going to put that onto my printed circuit board. Press escape. You can adjust the positions and size and everything. I think possibly we ought to increase the size of that a little bit. Let's make that 150 or something. And there we are. So there's my printed circuit board. I'm just going to move my legend a little bit. So that's just what's printed on the top. That's the thing that has the picture of your resistor or your transistor, so that when you make the board, you know where the components go. It's just to help you. Now, if on the board outline, I now double click on the board outline. Sorry, I did that wrong. If I now right click on the board outline, you'll notice it goes checkered. But there's this really annoying window that pops up. If you press escape, that one goes away, and then you can then go to these square boxes and you can drag it. And unfortunately, you've got to do that every time you want to make an adjustment. Don't ask me why. The American company wrote it like that. Okay? So now right click, get rid of that window with the escape button. Up we go. And let it go as it would. And right click, get rid of that silly window and drag it in. Okay, now let's do view, 3D preview,